Hi, I'm ADampSponge, and I kind of want to make a video on electric cars and stuff because it seems like there's a lot of confusing and conflicting info. So I feel like just having like a little open conversation about it would be nice. So, a lot of people say that electric cars are like eco-friendly, and that just kind of isn't true. Been seeing a lot of ads and people say that electric cars are like eco-friendly, and that's not exactly true. While it's true that the like emissions don't come like out of the back of the car, it doesn't mean that there's no emissions total. It just means that there's no localized emissions. Because like gasoline has a lot of stuff that if you come up here and huff it a little, you're probably gonna lose a little bit of brain mass. The first thing that we should look at is how does an electric car run? Well, it drinks electricity and uses that to make it go. Now, you may be wondering, where does electricity come from? That's a complicated question that surprisingly has a lot of conflicting results. So, I'm going to put a little picture of a factory up there because not all ways that we get electricity is good. And that, I shouldn't put labels like good and bad on it. But definitely not environmentally friendly, you know? One thing I do want to reference is this graph. This graph is from a US government website that is trying to convey where our sources of power come from, you know? So they want to say that, bottom length is the year, top length is like side length is the percentage of it that gets turned into electricity. And because all these rates like vary like pretty much constantly, it's kind of hard to get an exact pinpoint location on what percentage is coming from where. So all we really should be looking at is the side of the graph. I'm not on a drawable layer. We should be looking at the side of the graph, doing a rough line over, 30 to 40%, high 30s to 40 natural gas. Yeah, that's a little bit off. About 20% nuclear. I think coal is pretty much the same. Yeah, they're pretty much the same is what it's saying. Wind, I would say 10%. Hydro and electricity. Just, I said electricity, solar. These are all just below. So these these three at the bottom combined, maybe 20, maybe a little bit less. But this is very conflicted information. And I'll kind of show you why. This is the website that this comes from. It's a .gov website, government website. It's supposed to be like a reliable source of information. But anytime that you try to look up different ones, like this is not a government website, but this website is saying like 72% is natural gas and petroleum, which is way, way off of this website that says, about 40% natural gas. But this website doesn't have any petroleum or like liquid combustibles. Because, I mean, I can tell you where I'm from, there are diesel power plants that, in like, usually in emergencies, they kick on. And, like, or, well, I say kick on, but people go to them, they turn them on. Usually when, like, there's a lot of draw on the power grid, or when there's, like, really bad storms and not everything is, like, running right. Sometimes power plants will have to get shut off for a little bit for maintenance, and they have to switch over to, like, the diesel generators, and none of that is provided on the government website, which is kind of strange, you know? Because if you kind of compare the two, if you assume that the natural gas is still 40%, then petroleum is 30. But over here, this adds up to pretty much 100, I'm pretty sure, because that's 40 plus 20 plus 20, so that's like 80. And then all the three at the bottom, roughly get to 20. So that's 100%. But they have a fuel source left out. The other websites point out, whoops, oh god, why'd that go all the way? Let's stop. What the fuck? I guess that these are jump to points. Okay, I didn't know that. So, yeah, but this website says that, like, nuclear 17, coal was 10. Go back over here, coal about 20, nuclear about 20. So all the rates kind of vary. So, let's go to a different website, see what they say. This is from the same type of website that kind of breaks it down more. It breaks it down to fossil fuel, which it combines natural gas, coal, and then forms a petroleum. It says the petroleum ones are really low. I'm just not quite sure how accurate that is. So, but it says natural gas about 43%. But if we go over to this one, natural gas doesn't ever go above 40. So two conflicting pieces of information on the same website. Okay, now just get this. There we go. 43 never goes above 40. This one renewable has a total of 21%. But when we go back over here, wind is definitely like a solid 10 is what they're saying. Both of these are under 10, which you could add two numbers up under 10 to get just above 10, get 11. But it's really hard to tell where these graphs exactly line up. So it's, this one says 10.2. That's roughly on point. Hydropower, which, do they even have hydropower? Yeah, they do. For some reason, my mind blanked a little and was thinking that there's no hydro here. But the hydro graph says about under 10. Here says 5.7. And a solar is 3.9. Which is kind of weird because that doesn't add up to what the other graphs. Those other graphs should definitely be a little bit lower, because if solar's below half, solar is equal to hydro here. So, yeah, there's a lot of conflicting things. There's one thing I do want to point out here. This, we should probably be doing this more often. Municipal solid waste. What that basically means is uh, like, like poop and stuff lets off a lot of natural gases, and when you like concentrate it into a source and burn it, it burns very, very well. And what that basically means is that there's a power plant at a like sewage outlet, and it takes the sewage, splits it into mass that's burnable and mass that's non-burnable. And I might have to double check on that. I'm pretty sure it's mass that's burnable, non-mass that's burnable, and then they just light it on fire, and then it powers like a turbine. It's basically like a nuclear thing, but with just, you know, burning poop instead of glowing rods. So we should be doing that a lot more because it's a very, very abundant resource that we keep just kind of wasting. Something else I found kind of interesting. For some reason they have a negative percentage here. I don't know where they're getting that from. If that's just like a typo or something. I mean, they have a negative there too. Like, is it costing more than it's giving us if it's negative? You know? Oh, a lot of conflicting things. Anyways, but I jump over here, another website. This one's just a .org, so it's from an organization. So they could be, any side is what that really means. Like .gov is a specifically government website. .org is an organization has paid for this. .com is that it's just a willy-nilly website. So, but this one has natural gas as 31% compared to over here where it's high 30s to 40s. Oops, wrong tab. So, but this one also says petroleum. It lists crude oil and natural gas plants, liquids, which is interesting because when you would say petroleum, I think a diesel plants. I I don't know of any plants that run specifically off of like crude oil itself, unless it just saying crude oil means crude oil products, and crude oil products is diesel. So is this just a roundabout way to try to not say like diesel? Kind of strange. Anyways, this adds up to 28%, which is quite a bit. The coal here is 17%. If we jump back over to this coal, that's about the same. It's close, you know. So coal close. Somehow there's a 28% somewhere, which, I mean, if you were to stack this natural gas and that, you'd get like the 70% that comes over here with this. Oh, God, stop. Stop. I just like your little highlights. I don't need to go to every little part of it. Anyways, the petroleum and natural gas source does add up here, which is interesting. This is kind of where, like, if you ever look up facts for like a school report, please look up like 10 to 20 different ones, point out the inconsistencies, and just basically average them all and say, hey, if I average enough of the statistic surrounding the same thing, I should get a somewhat accurate number. So cool that renewable energy 12%, which is a lot lower than what like this is saying, because that's saying all three of these equal 12. This is saying that wind is 10. And that's not quite right. And then nuclear is 10. Over here, nuclear is 20. And then we go into the wiki. And wiki's it's also a little different. Interesting enough, natural gas there, 32. Lower than the 40 here. But with these two combined, they almost make that 72. It's off a little, but it's still. I'm getting the general idea here that between petroleum and natural gas, that's 70%. That's a good solid number. It keeps coming up. Coal here says 10. Fission, which is like reactors, this one also says 10. And renewable at 12. So there's a lot of statistical stuff that's going on here. Basically, everything's inconsistent. Why? Why would everything be inconsistent? Well, let me make a new tab where I can draw on. Let's see. Basically, energy production is not a straight line. You do not consistently pump out the same amount of electricity hour by hour. This changes. It goes up, it goes down. Let's just do like a baseline, couple bumps, goes up, goes down, goes up, goes down. And then you have specialty cases where, like, you will have big spike and little spike. Where, like, this is like, the summer and the winter where people are just cranking their AC and their heaters and just overall just trying to stay in a better environment because the environment that's outside is not great. But then you have like here, which is like fall and spring, where outside it's pretty good. Fall and spring, you usually don't need to like temperature control it too much. I mean, there are some days, but like really it's not that bad. And with this, energy production also has a similar thing. Now, if it's a renewable source like wind and solar and sometimes hydro, they produce erratically, you know. Like it is like you are at the mercy of the wind and the light. With hydro, you more often than not, I would say, have a consistent output of power, but let's see how I want to put this. But this can be influenced still by the environment. If there's a lack of rain and your dam starts drying up, you have a lack of power, and there's a huge demand in power because it's so goddamn hot, all the water's gone, and people want to cool off, you know? So, yeah, calculating power numbers is tricky. But I would say, from averaging all of our information, that we can somewhat confidently say that 70% is from dino bones. You know, there we go, dino. Which is not renewable and is also not great for the environment. And what that really points out is whenever you're like, you know, whenever you're charging something, you are creating emissions. They're just not localized. They're not by you. They're here at this factory that is like producing large volumes in a single space and trying to like wreck one smaller environment rather than spread it all around. So I think it's kind of still like false advertising for an electric company to come forward and say, hey, we are eco friendly because our car does not produce emissions. Because it does produce emissions, it produces them somewhere else, out of sight, out of mind. That's basically how that works. Now, there is another issue. Um, yes, I have it on this tab, and I've drawn right over it. And that is batteries. Because batteries are kind of, oh, can't draw on that layer. I can only draw up here for some reason. But batteries are, you know, they're important for an electric thing because that's entirely how they run. Now, what battery stuff is everywhere now? Uh, yeah. Like if you were to just think the word battery, what usually comes to mind is lithium ion battery. What does that mean? Oh, it's basically telling you that it's a lithium based battery, which is a metal that conducts electricity better than most metals. It's not the best, it's just abundant and like good, you know? I don't know if conduct is the right word even. What word do I even want to use? Let me also turn off show layer boundary. That's what that yellow is. So, how do I want to describe this? Like, the amount of electrons that you can shove into a metal is really high for lithium. I have two little photos. These don't make much sense right now. This one is just supposed to represent like a solid lithium that you can mine, and this one's a liquid. These are the two ways that you can get lithium. Liquid, generally not the worst for the environment, and I'm gonna somewhat immediately retract that statement because it's. How do I want to describe this? It's still. It's not a positive, but it's not as much of a negative as other things, you know? Basically, how you get this is that you frack, you shove water into the ground, and when you bring the water back up, it has the material in it, and that's because you kind of shoved the water into like a vein of lithium, brought it back. Now you got watery lithium. So now what do you gotta do with that? Well, you gotta put it into like a pool and wait for the water to like dry out from the sun. And then once that's dried out, then you have to pretty much like electrocute it. For some reason, making a lithium both ways requires you to like electrocute it. So you are using this energy production to produce the battery. And I mean, there's more than just that. There's vehicles that like transport it. There's the usual cost to mining to this. But the way of refining the liquid stuff is not that difficult compared to other ones. I think there's also some chemistry that goes into this. Like you have to, you know, add like I don't know if I want to say like cleaners to it. Like there's like dirty solutions, there's clean solutions. They basically want to purify it to be as clean as possible, which is why they like dehydrate it. But when you dehydrate it, it just kind of has everything in it, so you kind of need to break it apart and make sure all the pieces that you have are clean pieces. So, but that overall, it's not that bad. The solid shit is really bad. You need to cook this shit to 1,000 degrees Celsius. What that is in English. Let's look at that. It's about 2,000 degrees Fahrenheit. You know, you really need to just cook the ever loving shit out of it. And then you need to electrocute it. I don't know why. I'm sure some sort of scientist has more reason behind it, but either way you do it, electrocution is for some reason a part of it. So not only do you have the normal like mining it, hauling it. Most of the time they use like explosives to get into it too, so it's you got explosive costs. I'm sure that's not great either. And and then you need to like use like heat. You have to get like enough heat there to make a large room 2,000 degrees, so you can like melt the shit out of it. And that's basically how they like purify it. So it's a lot worse. And the car takes a lot of lithium, if I remember correctly. Let's just double check. Since I got Google open, lots of people are asking us. About 8 kilograms. Let me. 8 kilograms, just under 20 pounds. So, let's see. Holy shit. A typical. This one saying that that fucking Tesla takes 62 pounds. That's a goddamn person worth of lithium. I don't know how much we can trust that info, but I'm just gonna say, since it's our only reference, that's a lot. So overall, electric cars, not not a great eco-friendly thing. Everyone keeps pushing for them, and every like state and stuff has its own. I should say every U.S. state has its own percentages of what am I trying to say? Percentages in energy, like production. Some places, they produce a lot of coal, so they use a lot of coal. Other places are like, well, we want to become more eco-friendly, so we put in a shit ton of like windmills and like hydro dams and stuff like that. That's a good thing for me to go to. Let's see. U.S. states with the most. These are some interesting queries. Coastlines, lakes, countries, tornadoes. For some reason, specifically black population. And then following up, white population. Jesus Christ. Everyone's a racist here. You know? Anyways, so serial killers, population, borders. Okay. We're we're a great place. With the most, what's the word? Renewable. Renewable energy. Texas. By the Motley Fool. Honestly, I wouldn't have thought of Texas. I mean, Texas has a lot of heat, which solar they would kick ass in, right? Yeah, I knew Iowa was really high on the list, I did not think California would be. Oklahoma and Kansas are also very surprising to be up here. And I can see why Texas, but Texas would not be my first thought either. So, I mean, the only reason I think Iowa is if you ever drive through it, it's just nothing but like cornfields and then the occasional like windmill, and that's it. That's a lot of what that is. Oh yeah, so if you're in Kentucky, your electric car is using less than 1% of renewable resources. By the way, we're just at this moment trusting the Motley Fuel website by face value. Please take all this with a pinch of salt. None of this is like 100% confirmed. So interesting though that Iowa highest percentage was 60% of its energy coming from renewable resources. Now, I have been through Iowa before. I will tell you it's moderately flat with rolling hills is how I would describe it. Um there are some variations but with a very like flat general shape of the land. It is very good for windmills and they're very much taking advantage of it. Any other interesting by state? For some reason it's alphabetical. Can I sort by I can. Ah, interesting. Did this sort? Oh, there we go. Holy shit, Texas. That's a lot. 1,000 megawatts per hour. Percentages. So, this is also pretty interesting because with this math, you could technically figure out what, like, you know, what percentage of electricity they need. What's also very interesting is Texas is kicking ass in the volume of shit, but it's not their total, like, their percentage is low, and that's just because Texas seems to just eat electricity for dinner. You know what I'm saying? They have such a high demand that they're, tripling and quadrupling their, the second and third place. But they just have so much energy requirement that it's just hardly making like a dent in it, which is very interesting. Because if you sort by, you know, percent of production, Iowa, not the highest amount, they're the third highest, but they're the highest by ratio of electricity consumed, which is very interesting. It means that they're very low budget required, type of place. Which I mean, it kind of makes sense. There's not a ton of big towns. It is just a lot of farmland. So there's by volume a lot less people. So, but South Dakota also up there. Also, oh my god, how little electricity does South Dakota use? If they're nearly hitting 60% as Iowa is, and they have a fourth of it, that's in the generalized statement is saying that South Dakota is using somewhere between a fourth to a fifth less electricity. But my words messed up. Is it fourth to a third? Because a third's bigger. I don't know. Let's not compare it to any other numbers. Let's just compare between these because this is generally a fourth, you know. But then they're equal in percentage of renewable energy. And that is all if this website is completely trustable, which we've seen like the numbers on electricity vary wildly. So it's very hard to pinpoint, if any of this is actually like accurate. You know, speaking of that, Vermont over here with about a third less of the energy consumption, but also only 1,000 megawatts per hour versus the like 40,000. Jesus. So that also kind of shows why statistics is not a race of numbers. It is a race of uh, what do I want to say here? I think the word is rationalizations, because like if we look specifically at numbers here, we could be like way off, because like Texas doing good, high volume, but if we rationalize, volume versus consumption, it's a little bit more of a drop off. So, which is why I always say like statistics are good. I love them, but dear God, do people make way too many assumptions and just like if they ever make a conclusion through statistics, they're hardballing like this must be the right answer. No, that is not the right answer. That is just a generalized information of where the right answer could be. It's not an X on the map. It's a you found the right island. Start digging. So I don't know whatever this website is. By the way, this website lovely. I don't know who this Lie Daily is. Lovely person for putting this all together. Hmm. I don't know what this is comparing this to. 1,000 megawatts per hour. Interesting. Which these numbers I would be more concerned about trusting. Um, just because at some point you would have to average this. Because I'm sure. I mean, this is Alabama specifically, apparently, but I'm sure there's some sort of averaging, rounding, something going on here because the sun's only out for quote unquote half a day, depending on what side of the hemisphere you're on, your latitude, longitude. That shit changes. Some people get like 13 hours a day of sun. If you're in Alaska, you get once every couple of months. Let's go find Iowa, Texas. Oh, there's Iowa. Yep, see, all invested into wind. Exactly what I was saying. I will say, driving through there, a lot of companies putting out solar. Iowa, not a super sunny. I mean, you could still get sunburned, but it's not like I don't think it's the best for solar. Wind, on the other hand, good. Wind also, you have to talk about its other environmental impacts. Many people say um because the machine's white, that birds have a really hard time of seeing it, and that they will kill themselves on it constantly. So please factor that into its environmental impacts. Let's see, where's Texas? All the way down to the T's. Texas. Texas got a solid chunk of wind compared to their solar. Honestly, I would think that their solar would be higher. It is fucking hot there. It is too hot. That in Arizona. Oh my god! You ever see a video of someone's tires melting? They live in Arizona, and let me tell you, that's not a good day. I've not only seen, I've known people that have lived in Arizona who their light bulbs start melting because of how hot it is. You know, which where there's heat, there is energy to be made. So someone crack up that Stirling engine in Arizona, unless it starts melting. What was the other one I was going for? California. California was also way up there. I didn't think I'd find this website. I'm so glad I did. California, heavy into the solar. Kind of makes sense. Californian sun, very big. Um, they do have a solid chunk of other biomass, which I think that is the poopy burners. If that's the poopy burners, good on California for that. Every state should be using that. There's no reason not to burn our poopies. So lots of like wood too. Oh, I will say there is some back and forth about wood burning in California because California has two conflicting things. One, they have forest fires out the wazoo, which is bad, which means that as a citizen of California, you should be like in moderation removing segments of plants that may cause fires. Because if there's a fire, everything gets fucked up. True, you're removing some plants, which isn't the most ideal strategy, but it's remove the plant where your house burns down. There's a clear option here, you know. But the other thing that they have going is that they've made it illegal to remove types of foliage because they're like, hey, plants make oxygen and that's good and we want that. And I'm just like, no, you're dumb. It's true that that makes oxygen, but that also makes fire if your thing that producing oxygen is so dry and brittle that it burns. And this is not like a one-time thing. There are, I believe they're called the great redwood trees that have become fire immune because their bark is so thick, which means that fire in California has become such an issue over such a long span of time that it's just nature's trying to adapt to it. And those trees are really, really old too, so it's been a long time. So, you know, California should smarten up a little and start removing some tree, not trees specifically. Usually, it's more like ground foliage, but at the same time, they should get into what is that called? It's not terrain manipulation. That's a segment of it. It's not landscaping. There's another word that really deserves to be in that sentence. I am just blanking on. But I don't know. The main thing in that sentence is please California start sculpting your environment to be less flammable. Please, it helps everyone. Anyways, something else I thought was interesting. They're geothermal, relatively high, almost as high as their wind, which is interesting because there's not a lot of geothermal in most ones. Because there's here in California, there's only 10 segments in this website that say geothermal, and one of them's a headline. No. So that's down to 9. Never mind, that's Georgia. That's also Georgia. So now we're down to 8. What if I put a T in here? Oops. Oh, God, that's not how you spell thermal. There we go. Okay, so now we're down to 7 because I didn't realize Georgia was spelled the same as geothermal. So we got Idaho, we got Hawaii. Hawaii, I thought would be a little higher. They got a lot of like volcanoes, which would mean that there is like stark temperature difference between different ground points, which is very useful for like a Stirling engine type geothermal. Nevada, I got a good amount. This one's got a little bit. This one's got a little bit. That's Oregon was the last one I passed. New Mexico. Skip the last one. Utah. I think California's got the most. That's Oregon again. I went the wrong way around. Yeah, California's got a shit ton at 11,000 megawatts per hour. And also, I will say, when I am generalizing with like how much each one has because you could have one really good machine that produces a lot of megawatts, or you could have many small ones, you know. So when I say a lot, it's more of just volume production rather than saying how many facilities it has, you know. I'm very happy with this website. I love this. I could kiss the person who made this. If this information's all accurate too, I'd kiss him twice. So, also, that's these ones are these white ones measured? I'm gonna guess so because there's numbers. That is that's my pet peeve, by the way. When you have when you have a map that's statistics and each place is colored by like for example, this one's colored by production and they leave some of them blank like this white. That white could mean one of two things. Either A, it's not there, or B, it's very little. And those are two entirely different things, and many people don't separate them. You know? Because not there can also mean not measured. And if it's not measured, you can't put it on the graph next to everything that has been measured. Because it being measured is the only qualification for it being on the map in the first place. So remember, if you do make like statistic stuff, only add relevant information, and if there's information that you think is good to add, but it's not measured under the same standards, just put it in a little side note being like, hey, you know, this state, and this state were not measured in their ability to do blank, you know? Also, I realize that this is a different tab. This is the one by volume. Holy shit, yeah, that's we did see South Dakota. So because this is what this is, or it's the percentage of volume, which is very interesting to see it on the map versus just straight numbers. Because straight numbers, oh my god, why is that all highlight? Straight numbers, you're more keen to just looking at like the top couple of percentages. And I mean, you could look at like, I would say when you look at numbers, just look at the first one. So like 6, so that's in its own league. 5, that's in its own league. A lot of 4s, those are all, you know, generally grouped together. You know, couple of 3s, some 2s, you know, good chunk of 1s. And then sub 1 goes on for fucking ever. You know? So, oh, that's lovely. That's a lovely little feature. You can see everything that's grouped by. I like that. This doesn't make this any more clear. This last one. I like the idea of making it go from white to a color, but any of the ones that aren't being shown here should be like blacked out because making them whiter don't make it easier to see. Honestly, it's easier to see if you don't hover this. So that's a little the only pet peeve for right now. So back to here. So I think that's pretty much it. Battery looked at 70% of like dyno shit. Yeah, that's me. The sponge. That's the car. That's the little car farts. That's the factory. And that's the background. That looks like all the shit I had to talk about. I guess final statement. Um, if you want to buy an electric car, know what your car technically runs on, because that electricity has a price, and depending on where you live, that price is different. You know. Also, the generalized statement of electric cars being like eco-friendly, stop that. The phrasing that you should be using is like localization, like emissions non-existent type of wording. You know, like the car don't fart. The car farts in a box halfway around the country or something like that. I shouldn't say it like that. That makes it sound like it's a lot further away than it really is. I would say yeah, probably like in an hour's worth, like an hour's drive away, is probably the nearest large box of car farts that's happening. What was the other thing I was gonna say? Energy measuring. We gotta start nailing that shit down. Cause like it's at some point it has to be measured in some volume to know how much you're outputting and stuff, but there's a lot of variables that make it so when you look over a span of time, that number gets really wonky really fast. Especially if it's like need dependent, like I said earlier, like diesel generators are all around America. We have a shit ton of them. Now they're not the primary source of electricity, but I'm telling you, those things run a good chunk of time. It's not like once a year, it's like once a week or sooner, you know? Sometimes multiple times a week. Just depending on where you live and the, energy crisis of that area. So, yeah, I hope you learned a little something. I hope you learned that I'm willing to kiss a person if they make a good looking statistic website that doesn't mislead people.